Let's talk about 5G smart ports. But first, what is a port? A port is a marine facility that contains docks where ships can load or unload cargoes like the one in Port Klang. However, over the past decades, ports have encountered a number of issues which can be resolved by transforming into a smart port. A smart port is more efficient, productive, and economically competitive considering it employs real-time data and a collaborative management approach to give more security, save energy, and do more with less. In short, they are automated ports that uses new technologies such as big data, artificial intelligence, Internet of Things, blockchain technology, and 5G connectivity to have better performance and environment. There are many smart ports located around the world, and one of them is the port of Qingdao, China. They had a field trial for upgrading the port to automated by leveraging Ericsson's 5G solution for more flexible and higher efficiency. Because of all the success they were getting, they agreed to explore commercial 5G network and solution for smart port as it was said to save 70% of labor costs. They then invested in smart and green ports development, making shipping more environmental friendly. But before there was 5G smart port, there was a 4G smart port. And the 5G upgrade was implemented because it has quicker transition rate and also 1000 times the capacity of 4G. 5G also allows the port to use more data while using less power to transfer data in real time and use the information from IoT system quickly and efficiently. And with 5G's beamforming technology, we would not have to worry about different signals getting lost due to different metal surface in the port. Later we discuss on how 5G smart port can be implemented. Thus, we suggest that Port Klang, Malaysia invest on upgrading their ports to smart ports to have access to these functionalities.
What is a 5G network? How it can be implemented in a 5G smart port? There are a total of 5 foundations of 5G, which are millimeter waves, small cell, massive MIMO, beamforming, and full duplex. Now, let's discuss how these 5 foundations of 5G can be implemented in a smart port. Nowadays, due to there are many electronic devices at the port, the bandwidth for the electronic device users is less and they will often receive messages slower or experience no connection at the port. This is because the radio frequency spectrum of the same bands have become increasingly crowded as most electronic devices use similar frequencies which are between 3 to 6 GHz on the radio frequency spectrum. Hence, the solution is to open wider bands on the radio frequency spectrum which are millimeter waves that have a frequency range of 30 to 300 GHz. Consequently, everyone will have more bandwidth. However, millimeter wave have a weakness. If there are many cargoes and ships or it is raining at the port, millimeter waves may be unable to pass through the obstacles. Therefore, people will receive poorer services. To resolve the problem faced in millimeter waves, small cell is introduced. Low-power mini base stations, also called as small cells, can be set up at the port. The main function of a small cell is to reroute the signals. Hence, small cells can be set up everywhere at the street lamp or on top of buildings throughout the port to form a massive network that acts as a relay team. Subsequently, users at the port can transmit and receive signals from other base stations at any location. Another foundation of 5G technology is massive MIMO, where MIMO stands for multiple input, multiple output. MIMO refers to wireless systems that employ 2 or more transmitters and receivers to simultaneously broadcast and receive more data. In comparison to 4G base stations which have only 12 ports for antennas, 5G base stations have hundreds of ports with more antennas to handle cellular traffic. This means that 5G base stations can transmit and receive signals from multiple users simultaneously. As a result, data sent and received by users at C ports may be transmitted and received quicker. On the other hand, due to the additional antennas, it will also produce greater interference as signals will overlap. Hence, this is why we require another foundation of 5G technology, which is beamforming. Beamforming is a traffic signaling system for cellular base station that determines the most effective data delivery path to a specific user while also reducing interference for neighboring users. For example, when there are two machines at the seaport communicating with each other, the signals will be bounced off by the nearby structures and overlap with other signals. Beamforming will assist in identifying the exact location of where the signal will be sent and the optimal path for broadcasting to decrease signals interference. This means that the base stations can now manage more incoming and outgoing data streams at the same time. Transceivers can only do one task at a time, either transmit or receive. This is due to a concept known as reciprocity, which indicates that radio waves tend to travel both forward and backward along the same frequency. Due to frequencies are traveling from both directions, there will be an interference. By introducing a full duplex, which is a 5G transceiver, data now can be broadcast and received on the same frequency simultaneously by routing the incoming and outgoing signals using a circuit. This is done to keep them from interfering with one another while an antenna is broadcasting and receiving data simultaneously. Thus, this technology may be applied at the 5G seaport to offer users real-time data while remote controlling cranes to load and unload goods on ships.
The first application we are applying in the 5G smart pod is the remote control of gantry and quayside container cranes. Typical crane operators' working conditions are difficult, and site operation can also easily cause fatigue, resulting in other safety hazards. By implementing remote control of cranes, it might be able to reduce and prevent the problem stated. Cameras and programmable logic controllers are installed on cranes to enable operators to carry out operations remotely from the central control room through video surveillance. One operator can control 3 to 6 cranes simultaneously, compared with 3 operators in rotation per crane before. This leads to a reduction of labor costs and improves the work environment safety and security. To do so, a single crane needs to upload 5 to 20 channels of surveillance videos, and high-resolution videos demand around 30 to 200 megabits per second of uplink bandwidth. Furthermore, a network delay of less than 30 milliseconds is required for the crane to communicate with the central control room. As a result, wireless network devices must fulfill the operations and monitoring needs of cranes and terminal operating system components. In this case, 5G can provide adequate bandwidth and low latency support for the video upload and reliable PLC communications for the remote control of cranes, significantly decreasing costs and lowering the barrier of restructuring, and the operators can work from the smart pod control room.
Next, cross-vehicle control of IGV. The Intelligent Guided Vehicle IGV integrate at least 4 cameras, sensors and radars which allow them to move automatically, which avoid the objects on the way and offload the carried container at the designated spot. IGV knows when and which container was picked up, placed and repeat the same steps for the next container. All the data will be uploaded onto the main computer in the control room. IGV relies on the 5G network because 5G can provide better network support for these applications by ensuring no path cross connection. This could avoid collisions when the network is abruptly disconnected. For example, when an IGV stuck in operation field, operators use onboard camera to monitor around, spot problems, remotely control the IGV to get out of the area.
Another implementation that we are thinking of applying in a smart pod is video surveillance and AI recognition. It uses AI-based identification of container IDs from every container by using crane cameras and automatic cargo tally, such as the optical character recognition system. This could be convenient for monitoring and keeping a record of all the containers. This application also works as a security protection for a safer work environment and prevention of major accidents, where it has an intelligent analysis of operators' facial expression and status. For example, there will be alarms when the application detected a worker is not wearing a helmet at the site. Besides that, it could also help with the operation management in the pod, such as recognizing the cargo. Robots and unmanned aerial vehicles could be used for rapid and intelligent inspection around the pod. One of the reasons for implementing this is due to the fact that 5G is able to support the backhaul of multi-channel high-definition films and sensor data with its enormous bandwidth and large connectivity capabilities. 5G in conjunction with edge computing and AI can aid in synchronization and coordination of pod devices and production systems. This enables more jobs to be completed without manpower, enhancing port intelligence and operational efficiencies.
Another 5G technology that can be implemented in smart port is the autonomous drones. With the features of advanced AI-enabled object recognition, the smart port is easily monitored and the crimes can be easily tracked. This enables the drones to detect the object when flying and allows the analysis and recording of information on the ground. The autonomous drone installed with the camera will provide the real-time video streaming and send it to the central interface to watch how the operation works. They are not limited to collecting data from the air. It can also test aquatic and underwater models to gain information on the quality of water, to carry out inspections and maritime surveillance. It is capable of navigating the water surface and measuring the water depth, especially the unreachable area. Due to the 5G low latency and processing capacity, the autonomous drones are becoming a reality, and their utilization is going to include ship-to-shore deliveries and service inspections. The drones are able to respond quickly to the environment changes.
One of the technology used to enable the 5G wireless network at a smart port is device-to-device communication. It makes it possible for devices to connect to each other with or without the help of network infrastructure like access points or base stations. Because it doesn't rely on a base station to transfer data, it has a number of advantages, including reduced network latency, increased network coverage, system capacity, and improved spectral efficiency. By allowing an unenclosed device to communicate data through a closed device in D2D communication, the system coverage is increased. Hence, it is suitable for proximity-based data sharing services. To reduce network loss and unavailability due to network device or path failure in a smart port, network redundancy is crucial. It functions as a backup system to rapidly transition network activities onto a redundant infrastructure in a situation that a network breaks down unexpectedly. This ensures the least amount of downtime and the network services are maintained. To implement alternative network channels for network redundancy, standby routers and switches are frequently used. Hence, 5G can also be used as redundant connection to reduce network congestions as it has high bandwidth. The OSI third layer, which is the network layer, is to transfer data between hosts that are located in different networks by allocating destination and source IP to each data segment to choose the best logical path. Network slicing allows building several networks on top of a single physical infrastructure. In smart ports, wireless sensor network and remote devices have become the integral components. The three primary categories for 5G services are enhanced mobile broadband, massive machine-type communications, and ultra-reliable low-latency communications. Therefore, network slicing can meet the requirements by dividing the physical network into various logical networks in accordance with their needs. As an illustration, MMTC are intelligence automation that use in smart ports to operate and monitor end devices intelligently. Sensors that install to the container to track real-time location and temperature require a connection to 5G base station will produce a significant amount of data. Additionally, real-time video surveillance monitoring of ports activities under eMDB demands a strong connection and faster throughput. Also, high-resolution cameras and sensors are included in smart guide vehicles, which under the category of URLLC to increase port efficiency and safety. Therefore, to implement the above scenarios, 5G network slicing with software-defined networking and network functions virtualization architecture must be implemented. Each slide will be divided into its respective services, such as infrastructure as a service, platform as a service, and application as a service to handle the traffic load effectively. Network function partitioning can help to maximize available bandwidth, power, and data rates. As a result, it helps ensure that resources are used efficiently and effectively.
The next layer is the transport layer. The transport layer is to provide the communication services directly to the application processors running on different hosts, which collecting message segments from applications and transmit them into network layer. It breaks a long message into short segments and assigns them sequence number as identification. The protocols proposed for 5G smart port is Open Transport Protocol (OTP). OTP manages the end-to-end connection and is responsible for the congestion or flow control between source host and destination host. To provide a reliable data transfer and to improve the throughput performance, OTP is responsible for expecting a semi-reliable packet delivery service from the application switch sublayer. The status of the intermediate and destination buffers has an impact on the end-to-end congestion window variation and throughput. RTP sublayers are essential in the situation when the destination buffer is smaller than the intermediate buffer. Since 5G has a faster speed and low latency, the packet transmission speed will be faster and the delivery of message will be faster.
Application layer is the topmost layer of the OSI model. Its task is to ensure an application to have successful and effective communication with other applications on different computer systems and networks through different protocols. A few examples of application layer protocols are the Hypertext Transfer Protocol (HTTP), File Transfer Protocol (FTP), Post Office Protocol (POP), Simple Mail Transfer Protocol (SMTP), and lastly Domain Name System (DNS). The key functions of the application layer are providing a UI for users for interaction and enabling applications like emails and remote file sharing. 5G SmartPort has devices like video surveillance, real-time control devices, IGV, and drones. These devices require network communication like sending and receiving messages, require protocols from the application layer. With the implementation of 5G, real-time data monitoring and controlling is made possible due to the speed of 5G. Thus, it has a significant increase in productivity and effectiveness for the 5G SmartPort. Infrastructures like the video surveillance or drones require a GUI for users to view the data and send instructions in real time to control the 5G SmartPort's operations. This will allow the users to send instructions through 5G network and have no delay.
In conclusion, by adding 5G SmartPort features to the port in Klang, it will assist in managing the rising port traffic, improve efficiency and performances, and offer new user experiences in comparison to the existing technology.